Hey everybody, in this episode of Innovating the Industrial World, we're going to talk about control systems migration. And when you need a new control system, the difference between retrofitting and using existing infrastructure and ripping and replacing it with a new one. How we think retrofitting is pretty unique. How taking the time to plan and test means that migration can take place in 24 to 48 hours, which is like that in the industrial world. And how you can use emerging technologies to not only help test the new system, but also to use it after it's installed and after it's working in the future for training and testing to make those things work better. Hey everybody, welcome to episode 14 of our podcast, Innovating the Industrial World. I'm John King, CEO of Cross Company, your host, and I'm here with my really good friend, Robbie Peoples. Robbie, you want to introduce yourself?
Sure. I'm Robbie Peoples, the Director of Engineering for Process Solutions Group, and I'm excited to talk about migrations.
This is going to be awesome. So we're talking about today control systems migration and how we do something a little bit different than a lot of people. One of the ways that so when a company, somebody in the process industry, say a chemical or pharmaceutical company, and they're working on a new control system, you have to migrate that. So once you've chosen, oh my God, okay, what do we need to accomplish? We're going to decide to upgrade our system. And we've done all that work. Now it's down to, we got to make this thing work. We got to get it migrated into the new system. And we've got some pretty cool ways that we do that.
Mm-hmm. Absolutely.
We talk about, a really good analogy about how we think about doing that is that if you have your car and you want to get an oil change and you take it to the dealer, you're going to drop, you might drop it off or you might wait on it, and you're going to be there a good bit of the morning, right? You're going to be 3 or 4 hours. And then we liken how we do it to if you follow Formula One, which I do because I'm a car nut. An F1 pit stop is like 2.4 seconds to get all new tires and fuel and that kind of jazz. So we're talking about the difference in the migration from a dealer oil change and new tires to a 2.4 second F1 pit stop.
That's a great analogy to retrofit the existing system, have a small amount of downtime, and get it back up and running fairly quickly. Is something that's really beneficial for a lot of end users because it keeps the revenue flow, keeps them in production, and it phases it and spreads those costs out over time as well.
Yeah. So one of the things we want to talk about a little bit is like, okay, what is normally, and we sort of jokingly say that at Cross we're geeky smart and super nice. So this is what we think is a really geeky smart way to approach this problem that a lot of other people don't necessarily do. So what's the dealer oil change? So what are most people doing that causes a lot more downtime?
Well, what's easy for integrators is really just to build a brand new control panel and put it in place, right? But to do that, you have to have a cutover method that can be extensively long, could be days, could be weeks, could be months, depending on how large your system is. The difficult thing to do is retrofitting. So if you don't always have an existing footprint to use or new footprint to use, and you have a legacy system and you want to move it over, retrofitting is a great way to do that. It minimizes your downtime. But from an engineering perspective, it's definitely more challenging to do that for sure. And we feel really confident about our processes. We've honed it over the years, and it's really come to be a good solution for
one of the reasons why I wanted to share this is that it's interesting how the idea came about. We were in our facility in the factory acceptance test room, we call it the FAT room. So that's when our customers are coming in to say, okay, this thing works the way we want it to work. And we were talking to a customer, and you were telling me about what we were about to do in a couple of weeks, which was there was a pharmaceutical company that we were putting a whole new control system in place, and we were going to do that in 48 hours. And I'm like, what? I mean, how does that happen? How are we able to go from the old control system to the new control system and by the way, in the industrial world, 48 hours is the 2.4 second pit stop. I mean, most people you would think that's going to take, 2-3 weeks, whatever, in an extended shutdown. Yeah. So that's kind of where we start, oh my gosh, we need to talk about this. I mean, it's a really, really interesting thing. So how do we go about doing that? I mean, what do we do to make that happen?
Well, in short, obviously it's a lot of planning. But up front, we have to clearly define, what the requirements are for the system and really map it out. And that's really what we call the FEED study up front that develops the functional design specification, or FDS is typically what we call it. And that is a living document that manages the project from start to finish. And it really, not only does it tell you all the steps to go along the way, the hardware, the software, the licensing, the engineering, the electrical panel design, the electrical installation, all of these things, the downtime, are incorporated into this document. And that helps us outline. In that particular customer that you referenced, I believe that was about a 6.5 year migration plan of a large system.
6.5 years, and we're going to swap it over in 48 hours. I mean, that's
Well,
amazing.
it slowly went phases. We did 2 to 3 shutdowns per year.
Okay.
And that was one of the last ones that you had witnessed.
Mm-hmm.
It was the next to last one, I believe, that you witnessed. And, after the first phase and everybody understands responsibilities, as we work through that, it just really gets like a well-oiled machine. And they go down for a few days and they swap it over. Now, of course, the devils are in the details. When you're phasing a system out, if it's a complete different platform, there's a lot of hooks, so to speak, because you have to have both systems up and running and talking to each other. Or if it's just an upgrade, it's simpler, of course. But retrofitting in an existing facility where they don't have any more footprint, that's what makes it challenges, and that's something unique that we do.
Yeah, it's pretty amazing. I mean, you mentioned before, like the dealer oil change is what we refer to as rip and replace. Like you'll have some companies that come in and they're going to rip out what you've got and replace it with everything that's new, and that's costly. I mean, think about all the different contractors you're going to have on site that are going to be doing their own planning to make all this stuff happen, and we're using a good bit of existing hardware to make that happen, right?
Exactly. Yep. What we really like to do up front is to thoroughly plan what the costs are going to be.
Plan.
That allows the end user to really plan the spend of the money throughout the years, or it could be one big shutdown. That's certainly an option as well. But either way, retrofitting that and defining that up front, I think, is a clear target for success. We have to all be on the same page. We have to all be held accountable for what the target is. And the tools that we do that with, we move from an FDS approval, then we go into what we call a DDS, which is a detailed design specification. And that's something that's really unique to us, that the format of what we use allows the end user, who is possibly more likely not a programmer, they don't know the scripting, they don't know the language, maybe they don't even know the platform we're moving to. This allows them, in layman's terms, to be able to read that document and confirm
in their words, exactly how it works.
I
think that's what makes it really, really different. I mean, there's lots of companies that you're going to talk to. They're going to have lots of acronyms. It sounds like the military. FAT, the factory acceptance test, the FDS, the functional design spec, the DDS, the detailed design spec. But what we think is really kind of unusual about this, and really kind of, again, the geeky smart, super nice, is that we're writing those things in the customer's language, in the customer's terms, so that they can use this, because it's plan. Somebody, I think it's a military saying, prior proper planning prevents piss poor performance.
Exactly.
So plan. Yes. That's how we avoid the dealer oil change.
Absolutely. And we've had multiple customers adopt the method that we write those DDSs in. It's very beneficial for them because they can train other operators to do that. And in some cases, the end user will write that for us. After we go through a couple of those, they'll write that for us and say, here's what I want. And so it gives us a very narrow target for success. That's exactly what we want. We want everybody to understand what success looks like when we do a migration, for sure.
And one way we do that, again, back to the pit stop kind of analogy, is that you can't imagine how much these teams practice. We're talking about planning, but also practice. So one of the things that we have a number of tools, there's digital twinning. So now the technology exists that we can actually create a control system, a simulated control system in an environment. And we have some pretty unique, I think, solutions to that. It'd be great to talk a little bit about that, how we put those in place, because we've been doing those for a long time. But the technology exists now that we can do things a little bit differently.
Yeah, absolutely. We've been doing simulations for a long time. And, what we found over the years is there's different levels of simulation that customers require. Digital twinning is a great method of really replicating the reactions of the system. That's something that usually you see the benefit behind that is when that customer can take that system and use it as a training tool throughout the years. They grow that system, they expand it, they maintain it, and they train operators on it.
So we can take that simulation environment, use it for training, which is a big deal for our customers. It also makes things go a lot smoother.
Yes. And there are other customers that they don't need that level of training. They already have methods of how they train people.
Yeah, they know how they're working.
Yeah, so there's no need to spend a lot of time doing digital twinning. But what we want to do is reduce risk and test to make sure the software meets exactly what the spec says.
And it's a whole lot better to find out in a simulation than it is after we're back up and running.
It's very expensive when you're sitting around on site, twiddling thumbs. You got operators, you got the production guys, you got the maintenance techs are there, process engineers, everybody's
the engineering
around.
firm, us,
yes,
control systems engineers.
Very expensive. So ideally, when you get to site, if you do a very thorough job at defining your specs up front, writing good test protocols that's reviewed and approved by all parties, and then implementing that simulation level, which I'll talk about 3 different levels of simulation here in a second. If you do a good job of that, by the time you get to site, it should be simply testing your I/O. Your software functions should be minimal tweaks and changes. They're not going to be large software changes if you effectively do your planning and testing up front.
And what Robbie's talking about testing I/O is literally all the electrical connections that this new migrated control system has to your plant. So that I/O is inputs and outputs. So that's just checking all those things to make sure that's right. But you're going to have to do that anyway. That's part of the 24 and 48 hours.
It is.
But instead where we can, our solution really only focuses on, which is kind of is really, really unusual. We can make sure that happens well. Because you don't have to do a lot of the other testings already happen, right?
That's right. Yep. So let's get into a little bit about the difference in simulations.
Yeah.
And kind of talk about that.
This idea of digital twinning, these emerging technologies.
Absolutely. Digital twinning is an awesome tool to use. Every customer that comes to us doesn't necessarily need that level of simulation. We enjoy doing it. We love doing it. We like geeking out on that stuff. That's cool. But it's not always cost effective if they don't need that level of simulation. If they have an existing process that the customer really knows how to run, they've been making that process for a long time, they simply don't need that level of training. And what we need to do is remove the risk to make sure the code actually functions properly, just like the spec says. And we can do that in a multitude of ways. And I typically call out 3 levels. I call it simplex, medium fidelity, and then high fidelity is really what I call digital twinning.
Okay.
And the simplex is a cost-effective solution that basically mimics equipment functions. It allows me to test interlocks, to test interactions on the process, just basic software functions to validate the software does exactly what we say it's going to do. And then, of course, medium fidelity, that adds some process characteristics in there. An example would be, say, if my drain valve was closed on my mixing tank and my inlet valve opens, you're going to see the level rise, and maybe we have an equipment module that's set to auto, and once the level rises up above the agitator blades, agitator kicks on automatically and starts mixing the product. That's something that you could do in a medium fidelity without actually having a digital twin, but you can verify the software does exactly what it's supposed to. So we try to do that so we can tailor to our customers' cost needs.
Yeah. Yeah, that makes sense. And then the high fidelity is like what you hear about and read. And this is kind of funny how this, also another funny story about how this started is I'm going to Robbie and our engineers saying, I'm reading all about digital twinning and tell me about how are we going to be using that? And he's like, dude, we've been doing that for years. We've been simulating things for a long, long time. But the high fidelity version is essentially where we do create a virtual environment that is your plant. Right?
Yes, absolutely. You model the process characteristics.
And when would you want to do that?
And like if you have a newer process and you need to really understand the reactions and what's going on, what kind of controls we really need to put on there. If you have the need to really train operators to have an ongoing, really accurate training program, that digital twinning is an absolute value for customers like that.
Yeah, it's huge. So really, and there's some significant cost differences. I mean, this simplex model that we've been doing a long time, you're saying, hey, I know what I need to do. I told you I wanted it to operate pretty much like I did before. Yep. So we need to do some that's essentially using a simulation environment to do some testing of the processes.
True.
The medium fidelity is where we're building in some more functionality around that. But you're not necessarily using it as a training tool. We're using it as a planning and testing tool. But that super high fidelity digital twin, that's when not only are we able to, and we're able to work with the plant to use that as a planning tool. Test. So we get to the 2.4 second pit stop. And it is a dance. It's orchestrated. Everybody's got their role. Everybody knows what that role is. But once you're in place and that 48 hours is done, now you can use this digital environment to train and to train new, because turnover is kind of a big deal in the industrial world these days.
Absolutely. The knowledge base in the industry has retired or is retiring. So training those new operators that come in.
Don't go anywhere, by the way.
Yeah,
you can't retire. For sure. Yeah, there's a good bit of technical knowledge. That's one of the reasons, again, geeky, smart, super nice. We need to bring that. This is how we make that technical knowledge, but put it in the language and in the terms of our customers, where we're doing these retrofit migrations. So you might say, hey, I just need, I want to upgrade the functionality of this. I want to get the latest technology. Maybe we work on a lot of stuff that I think is obsolete. Where literally, if something happens to it, that plant's going to have a lot of downtime if we don't migrate.
Absolutely. Let's hone in a little bit on the retrofits.
Okay.
Because that's something that's very unique that we do, and it's challenging. They are the most challenging projects that you can run up against, for sure. So if you are confined in your footprint, you don't have additional space to just add a brand new cabinet, and you need to take the existing hardware, and we need to shut the plant down and bring it back up and replace, let's say, this particular cabinet. So we have the capabilities. We're a UL 508A design and build panel shop to analyze the existing panel, come up with a demolition plan of what needs to be removed, and have a retrofit panel to fit in there with new pre-tested, pre-wired as much as possible hardware, and then you would have to re-land the I/O. So it's
part of that orchestrated pit stop. Okay, somebody's job is to go, and we got it.
Yes, very orchestrated. We've run 24-hour shifts before on plants to get them turned around very quickly. Because you're physically limited. You can't put electricians on your shoulders. I'll do the bottom half of the cabinet and you do the top. You know, one person can fit in that space at one time. So every wire has to be clearly defined, understood, and detailed going into that. But it works really well when everybody's on the same page.
So our team, our geeky, smart, super nice people are coordinating everybody on this team. Like you mentioned, holding everybody accountable. Everybody's got a plan. Everybody's got a role in that plan. And we're not only coordinating our folks in the pit crew, but we're coordinating a whole lot of other folks, right?
Correct. Yeah, typically when we go through the on-site process, typically our processes follow deployment of some sorts. And we do some stability testing to make sure the system's up, stable, running. Then we move to commissioning. We commission I/O. We check out I/O points. And we're usually doing that with the E&I firm or E&I electrical contractor, or in some cases, the maintenance facility takes care of that at the plant. We run through I/O checks, and then we run through what we call software acceptance testing. So you heard me talk about earlier, we perform testing on simulation in the office. That exact same testing is done, but it's done with real-world I/O at that point. Once the I/O is checked out, to make sure we have a full functioning system and sign off. And then lastly, interlock checks are happening. And then once that happens, that system is signed over to production. They're allowed to start and introduce media into the system.
There you go. We can get that done in 2.4 seconds in the industrial world.
In the industrial world, yes.
Cool. Kind of neat.
Yeah.
Well, hey, everybody. Thank you so much for tuning in to Innovating the Industrial World. That concludes episode 14. Robbie, thank you so much. That is a really, really cool thing. Absolutely. If you've liked what you've heard, please subscribe and like. And also, if you have any questions or comments, we would love to hear from you, and we're monitoring that all the time. So please put your comments below. Thanks, everybody, for tuning in. We're looking forward to talking to you next time.
Thanks, John.